welcome to another online lesson. Today we are starting to look at the homologous series and we are going to be kicking things off by looking in particular at the alkanes. So our learning intentions for today are firstly to define a hydrocarbon and homologous series and to describe the alkane family. So at the end of the lesson you should be able to describe a homologous series and describe the alkanes in particular. So draw the first 8 alkanes, tell me their names and their formula. They also have something called a general formula which you need to remember, and I'm also going to cover some of the uses of alkanes. So let's get started. Okay, so first things first, let's look at this word hydrocarbons. We can split it in half here into hydro and carbons. When we do that, from hydro we get hydrogen and from carbon we get carbon. What that means then is that hydrocarbons are compounds made only of hydrogen and carbon. So when we are dealing with hydrocarbons, they are compounds made only of hydrogen and only of carbon. There are no other elements involved. Now, a homologous series is our next definition that we are going to look at. It's a group of compounds with the same general formula, similar chemical properties, and gradually changing physical properties. So when we are thinking of physical properties, we are thinking of their state at room temperature, melting and boiling points. So as we go through a homologous series, these things gradually change. They'll either get gradually higher or gradually lower. In terms of chemical properties, how volatile are they? How reactive are they? And what kind of reactions do they take part in? Their general formula is something we are going to come back to in just a moment when we look in detail at the alkanes. So I'll say that again. A homologous series is a group of compounds with the same general formula, similar chemical properties, and gradually changing physical properties. Now, this is a definition that you're going to want to remember. It's a question that comes up all the time in assessments, and it's an easy one to get. All you have to do is remember your definition. So let's look in particular at the alkanes. Now, the alkanes are the simplest homologous series and they only have carbon-to-carbon single bonds. Now, when I say the word single bond, what I mean is that between one carbon and the next, there will only be one line indicating a single covalent bond. The first 3 members of the series are methane, ethane, and propane. And as I said, between each carbon, there's only one line, which means single bonds. And you will have noticed as well that all their names end in "ane". So if you come across a hydrocarbon and its name ends in "ane" and "ane", it will be an alkane. Now, when it comes to the homologous series, there is a set of prefix which tells you how many carbon atoms there are in a molecule. If the name of the molecule begins with meth or meth, it means 1 carbon atom. Eth means 2, prop means 3, but is 4, pent is 5, hex is 6, hept is 7, and oct is 8. Now, it's a really good idea for you guys to make a note of this. There is a copy of this table in the pupil booklet which will be available to you guys. However, if you prefer to make your own notes, I advise making a note of this in your jotter. Another really good thing to do would be to come up with a mnemonic to help you remember the prefixes for 1 to 8 carbon atoms. A mnemonic that I sometimes find useful is monkeys eat peanuts but prefer hairy haggis occasionally. Now, maybe that doesn't make too much sense to you, but makes sense to me. The point of a mnemonic is it's something that you come up with that helps you remember. So if anyone comes up with anything interesting, let me know. Now, something else that is important when we are looking at hydrocarbons and homologous series are full and shortened structural formula. When we are dealing with molecules like methane, ethane, propane, they're quite small, they're relatively easy to draw out. However, it might be quite time consuming to have to draw a big structure with 10, 11, 12 carbons in it. And with shortened structural formula, we don't have to. So full structural formula shows all the bonds between atoms as straight lines. So for example, this is propane, and you can see all 3 carbon atoms attached to all 8 of the hydrogen atoms involved. Our shortened structural formula, on the other hand, will show the atoms that are attached to each carbon atom in the chain. So here's what we do to get the shortened structural formula to save us from drawing the whole molecule out. We are going to divide the molecule into units of carbon atoms, like so. So if we go from left to right, we have 1 carbon atom attached to 3 hydrogens, so it would be CH3. In the middle, we have a carbon atom attached to 2 carbons, so it will be CH2. And on the end there, we have another carbon atom attached to 3 hydrogens, so it's CH3. Our full structural formula is the whole molecule drawn out with all the bonds shown as straight lines. Our shortened structural formula shows atoms that are attached to each carbon atom in the chain. Okay, so just to get the hang of full structural formula and shortened structural formula, we are going to complete this table for the first 8 members of the alkane family. Now, I will do the first 3 just to start you off, and you continue on with 4 to 8. So remember our prefixes. 1 carbon atom means meth. ANE means it's an alkane. So it only has 1 carbon atom. That carbon atom can form 4 bonds, and it is bonded to 4 hydrogen atoms. So we start by drawing our 2 carbon atoms bonded together with that single bond, remembering that carbon forms 4 bonds and the other 3 are 2 hydrogen atoms. Its shortened structural formula then, if we split it into the carbon atoms, is CH3, CH3. Its formula then, so how many carbons and how many hydrogens does it have, is C2H6. Our prefix for 3 carbons is prop, so propane would be 3 carbons long, so 1, 2, 3. Make sure there are 4 bonds coming from each of your carbons and fill in the spaces with hydrogen. For our shortened structural formula, again we are breaking it into the individual carbons, so it will be CH3, CH2, CH3. Our formula, which is how many carbons, how many hydrogens, will be C3H8. Now remember, when we are naming 4, 5, 6, 7, 8, to use the prefixes from before and make sure they all end in ane. So the prefix for 4 was but, so it will end in ane, so butane is the alkane with 4 carbons. The prefix for 5 was pent, like a pentagon has 5 sides. Pentane has 5 carbons. A 6-sided shape is a hexagon, and the alkane with 6 carbons is hexane. Heptagons have 7 sides, and heptane has 7 carbons. And as you may have guessed, an octagon has 8 sides, and octane has 8 carbons. So I'm going to leave the rest of this table blank and you should fill it in yourself. Once you've done that, come back and we will continue with the rest of the lesson. So the definition for a homologous series was a group of compounds with the same general formula, the similar chemical properties and gradually changing physical properties. So each homologous series that we are going to learn about can be represented by a general formula. Now in a general formula, the letter N represents the number of hydrocarbons. And Now in a general formula, the letter N represents the number of carbon atoms in the molecule. And if we know the number of carbon atoms, then we can work out the number of hydrogen using the formula. So let's look at methane, ethane, and propane. Now, methane has 1 carbon and 4 hydrogens. Ethane has 2 carbons and 6 hydrogens. Propane has 3 carbons and 8 hydrogens. Now to go from 1 to 4 and 2 to 6 and 3 to 8, we multiply the number of carbons by 2 and then add 2. So to go from 1 to 4, we multiply by 2 to get to 2, and then we add 2 to get to 4. 2 times 2 is 4, add 2 is 6, 3 times 2 is 6, add 2 is 8. The general formula then for all of the alkanes is CnH2n plus 2. So if N is the number of carbon atoms, then there are 2N plus 2 hydrogen atoms. So just for talking's sake, if I have 10 carbon atoms, how we work out the number of hydrogen atoms is we substitute the number 10 in for N. So we do 2 times 10 plus 2, which gives us 20 plus 2, which is 22. So in an alkane with 10 carbons, there will be 22 hydrogen atoms. So we have looked at the first 8 alkanes, we have discussed the general formula for the family, and now we are going to move on to their properties. So as we move from methane to octane, as we descend the series, you will see that the boiling point gradually increases. So methane at room temperature is a gas. And because the boiling point increases, we move from methane to octane. By the time we get to octane, octane is a liquid at room temperature. So as you descend the series, again going from methane to octane, the alkanes become less volatile. Now remember that volatile is how easily a substance evaporates at a normal or room temperature. So in the winter when it's much colder, we use more volatile carbons in our petrol. It means it's easier for us to burn them to get fuel when it's such a low temperature. In the summer, when it's warmer, we use less volatile carbons in our petrol because we don't want the fuels in our tanks to ignite itself and cause a fire. So, as you might have guessed, alkanes are used mostly as fuels. Methane, our smallest alkane, is used for cooking and central heating. If you have a gas stove or gas central heating, the gas that's powering that is methane. Propane and butane are used as camping gas. Butane is also the gas used for barbecues. And octane is used in petrol. Now I have included some pictures down the bottom to help you visualise. For octane we have a petrol pump, we have a gas canister for propane and butane, and for methane I have included a cow. Now you might be thinking, Miss McPherson, cows? You told us that methane comes from fractional distillation of crude oil, and you are right, it does. The methane that we use as a fuel in the uses I've just given you there is definitely from crude oil, but in the process of digesting their food, cows produce a lot of methane and they get rid of most of this built up methane by burping. Now that takes us to the end of our lesson on homologous series and alkanes. So I hope that by the end of this lesson you are able to tell me what hydrocarbon and what homologous series is, and also to describe the alkane family by drawing the first 8, telling me their names and knowing their formula, full structural formula and shortened structural formula. We also discussed general formula and described the uses of some alkanes. Thank you guys for tuning in, and I will see you all in the next one. Bye guys!